Good afternoon, everyone. How's everyone doing? Good. Whoa. So many cheers. Before we get started, can we give a round of applause to the organizers? Perfect. Thank you. That's going to confuse everyone else outside. Finish super early. Everything that's new in C#, 30 seconds. We're going to catch up with all the features from C# 9 up until 13. Let's see how we do this in 40 minutes. There's a lot happening in the language. And if you do have any questions afterwards, I'm Filip Ekberg. Ping me on Twitter, send me an email. Let me know what you think about C# and .NET, or if you just want to discuss programming in general. So we have a lot of stuff to go through. There's been some changes to C# recently. Over the past 2 decades, a lot of features have been added to this amazing programming language, taking inspiration from F#, Java, Python, whatnot, all the other programming languages out there, looking at how we can build better applications and how we can adapt to how to build applications today, mobile, web, and so forth. So there's a lot to go through here. Some of these language features change how we look at the architecture of our applications, be it adding generics or async and await, using resources more efficiently. So there's a lot that we can learn from the language. So if you want to jump on C#, you should really stay on the latest version of .NET. So if you install .NET 9, that's coming out in a couple of weeks, you'll get all the available features from C# 13 and back. Now, this here is a little bit of truth, because you can actually use C# 13 with even .NET Framework 1.0 if you so want to. Because some of these features are just syntactic sugar. Basically compiles down to the same IL that's been available for a long time. But it's not supported, so if you really want to get the best out of .NET and all the performance, all the language features, you should really try to stick to the latest version of .NET. How many of you in here are using .NET 8? Almost all of you. .NET 9? OK, a handful. That's amazing. That's daring. It's going to be released in like 1.5 weeks. There's still some time for Microsoft to change things. Will be interesting in a couple of weeks, right? So now, with that being said, .NET 8 is actually the latest long-term support version. Every second year, Microsoft releases a long-time support version, which means that it's going to be supported for a longer time. Every second year in between that, they release a short-term version, which is now .NET 9. Now, I would recommend that you always try to upgrade, because if you wait until every long-time support version, there might be some breaking changes that it's going to be a little bit problematic to adapt to. So just try and stay on top of things and upgrade to the latest version. Now, being a consultant, that's quite easy for me to say, because I get paid to upgrade and spend a lot of time on the projects. So just do that, and I'll be happy. I do understand, though, that it can be tricky, and some people are still stuck on .NET Framework. And there's a lot of help out there to get you upgraded. There's upgrades assistance and so forth. But that's the side of this talk here. Now we're going to focus on talking about C#. We're going to go back to C# 9, which was introduced with .NET 5. .NET 5 was the first version of this new idea of one .NET that runs on all platforms, works on every system, can be built on any system, and so forth. And it actually has become quite well and quite good with the latest version as well. So with .NET 9, we got the introduction of records, which is a new way of creating and producing reference types. Instead of building classes, we can use records to get a lot of pre-built functionality. We get built-in immutability, we get value-based equality, and a lot of helpers to avoid multi-threaded problems. We'll look at an example of that in just a moment as well. There's something called init-only setters. If we're using auto properties, we can use this feature to allow us to create immutable objects. There's top-level statements to help us build minimal APIs. There's pattern matching enhancements. There's target type new expressions, and some other things. Just wait with that. Target type new expressions is one of the features that will require you to jump on a new version of .NET. Some of the language features require runtime functionality to work, and this is one of them that requires that. And some of them are syntactic sugar that just compiles down to supported IL. Then there's a whole bunch of more things. Like being the 9th iteration of the language, there's quite a lot in here that was added in C# 9. The non-bolded things are probably stuff that you'll never use and never hear of. If you have heard of this and you worked with them, please let me know, because I'd be very intrigued to know exactly where this would be applicable. But the bolded stuff, record types and the init-only setters, are some really amazing features added to C#. But before we jump over to Visual Studio and take a look at that, there's one thing in particular that was really important with the release of C# 7, 8, and 9, and that's pattern matching. This is something that's been available in other programming languages for a very long time. But it took a little while for C# to adapt and actually add things in the language to support this. Now, pattern matching is all about looking at structures of a type and looking at what something can be deconstructed into, what kind of property values and so forth that it has. A very simple use case would be to look at if a service call was successful or failure, and then do something based off that. So it's really just, if you boil this down to matching on a type and an attribute, that's really what pattern matching is all about. And we've been able to do this ever since C# 1 through 6. With a simple if statement, we could very simply say, well, if the thing I'm looking for has the same type as what I'm looking for, and I also want to compare some property values, then I want to enter this if block here. But the problem with this code, even though it works, is that it requires me to typecast myself. I have to be repeating myself. And if I'd want to check on a particular property on that concrete type, I would have to add a little bit more code to do that. So in C# 7, Microsoft found out that so many other programming languages have pattern matching. So why don't we add that as well? So with that being said, we can now use a switch where the input would be the type that we are writing patterns for. Basically, I'm taking my type here, and for each case, I can check, is it the type that I'm looking for? I don't have to do any typecasting myself. I can check property values, and I don't have to do anything more than what we would expect. Although, like, by C# 7, I wouldn't write code like this because it's more of a boast. There's a lot more code that I have to write. And frankly, this doesn't look as nice as some of the other programming languages out there. However, one of the things you'll see with C# and each iteration of C# is that it builds on top of features already existing in the language. They have to start somewhere, and it's hard to build something very nice from the beginning, right? If someone asks you, can you build the perfect product for me? I'm going to say yes, because I'm a consultant. However, it's quite tricky, isn't it? So they have to start with this type of pattern matching here. And we can match on the particular type, which is a type pattern. We can have the default case, which would then match on nulls and whatever other type that would be. But at this point, I wouldn't use this. But what I did like was that with C# 8 and C# 9 and onwards, they added support for something called switch expressions, and also adding support for many different types of patterns as well. So in this case here, we're going to switch it up a little bit, pun intended. We're going to take the input here, and this is what I want to create patterns for. I want to produce a result based off my input object. And basically, I just fill this with expression-bodied members, or looking like expression-bodied members. I have a pattern that I want to match, and then I have a return type that I want to return. So if we take the other example I had earlier, we can say here that I'd like to know what fruit this is. Now, I'd like to get a string representation of what that is. And if it's an apple, this is a type pattern. It's checking that it's set to an instance and that the instance matches that particular type. And then I can return a value. It doesn't have to be an integer, it doesn't have to be a string. It can be a method call that returns something else. Now, again, this could be very simple, and that's what's returned. This is the most simple pattern that you can write. There's a lot more patterns in C#, and this is where it can become a little bit confusing. Because we have the type pattern that I just showed you. We also have a positional pattern, which is used when you deconstruct an object. Looks very much like a tuple or tuple, depending on how you like to pronounce that. There's ways to match on property values. There's ways to match on exactly what a tuple contains. We can have relational patterns, meaning that I could check a property value. For example, if I have a person with an age property, I could say, this person has to be over 20 years old, and write that in a very concise and nice syntax. We can use these together with a conjunctive and pattern to say that it has to be over 20 and under 40. Or it has to be some arbitrary numbers. We can also match on lists and ensuring that the lists are set to an instance, that they have one or more values. We can check where it contains certain values at the start or the end. We can slice off portions of the list. There's a lot that we can do with that as well. And then if our patterns become quite tricky to read, we can use something called a parenthesized pattern to add parentheses around them, just like we do in any normal code as well. But if we start doing that, maybe we should rethink the code that we're writing. We can also negate any pattern, which is, personally, I only use this to negate null. Null is also a pattern. So I could say, if my object is not null, that's using the negated not pattern. And all of these together can be used to create a recursive pattern. So first we can check the type, then we can check a property, we can deconstruct an object, and so forth. So enough slides, let's jump over to Visual Studio. So first, before we look at pattern matching, I'd like you to show a couple of things. We have, at the top here, we have a file scope namespace. I no longer have to wrap my entire class or my entire file in a namespace. Instead, I can simply say that this entire file belongs to this namespace. This here is an abstract record, which will really just be a class with the primary constructor, which requires these two parameters. This is really a record class, but the class keyword here is redundant, so I don't have to write that. If I take this code, this little portion here, I copy that and I paste it over in SharpLab. Look, it was already pasted. Here is a couple of things. This here is the right-hand side here is actually what's decompiled. So on the left-hand side, we have the code that I wrote. On the right-hand side, it's all decompiled into equivalent C# total versions. So this here is a class that implements IEquatable of the same class. It has two backing fields so that it can set the values that I say in the primary constructor, so the number of attempts and test date. And then, if I scroll down a little bit here, we can also see that there's a new thing called Init. So this here is a property that simply works with the backing fields. The Init keyword was introduced in C#9, which really just says that this can be initialized, but after that, you cannot change the value. So after that, it's immutable. This is good because we don't really want to change values on any objects that we created, especially in multi-threaded environments, async await, parallel programming, and so forth. Now, the constructor that it introduces is similar to the primary constructor that I have here. It takes the number of attempts and test date, sets the backing fields, and then you're not allowed to do that anymore. Further down, we're not going to spend much time in here. I just want to show you this. The equality implementation or implementation of IEquality means that it's actually going to compare the values of two different objects instead of comparing the reference. It will first compare the reference because that's the fastest check to do. If it's the same reference, the values are probably the same as well. But if that's not the case, that the references are different, then it's going to go ahead and compare. Let's see here. It's going to compare the backing field of the other, It's going to compare the backing field of the number of attempts with the other backing field of the number of attempts. So it's actually going to compare the values of the properties that we've defined here. Super simple. Nice and concise syntax of defining reference types, which gives you value-based equality and immutability. All right, so let's look at how we can use this. I've created a new reference type here, or this new record, in a method that returns the base class. So I actually have two subclasses here, subrecords, passed and failed. So I'm going to return that from here. And just to show you how I change that value, we can use this new with expression to say that I'd like a new version of this record with a slightly changed value. And then I'm going to return that from this method. So that's a couple of things that were added in C#9. And now let's look at the pattern matching enhancements, or actually the pattern matching, how that works. I'd like to create a variable called outcome that's based on this test. And I'd like to add a couple of patterns to determine what this actually is. What I can do now is to say that, well, if it's failed, I'm going to return failed. And then for anything else, I can use a discard. And I can't spell, but there we go. So for anything else, if it's null, if it's a different type, in this case also if it's passed or if it's just a base class, then this will run this discard or this switch this pattern as well. Now, to make it a little bit more interesting, I could say, well, if it's passed and one of the property values, for example, number of attempts, is less than 5, then I want to say that you've passed. This means that if you have more than 5 attempts, then you should probably retake the test or whatever this is. And it also has to be, more than 0 or more than 1. So I can use these together to produce really nice pattern, which is easier for us to use when discussing things with, for example, stakeholders in the business. Patterns allows us to make it much easier to express ourselves when we're constructing patterns like this here. They're not constrained to be only used with the switch expressions, though, and I'll come back to that soon. Here are two different things. So first, we check on the type pattern, then recursively, it will check that this instance has the number of attempts less than or more than 1, and more than 1. I can also remove passed here, which will check if it's passed, failed, any type, as long as these property values have these different values set to it. This here will in fact check if it's not null. So a rather ugly way to check if an object is not null, test is set to an instance. Super readable. If you want to see something that's not readable, now, if we go back here past, what happens if I negate this? Right? Becomes totally, well, now the Visual Studio keeps helping me, but if I do this, it's really difficult for me to know if this is this going to match if it's null, is it going to match only for passed and or failed? Is it going to include this portion? What happens if I had or here in between? And not? Like I can negate anything, right? All right. Going off on a tangent. We should write readable code, but this is just an illustration that we can write patterns that are not readable at all, which is a little bit problematic. One more thing I want to show you here. Look at the top here, which is not related to pattern matching, but there's a global keyword which was introduced in C#10 to use global using directives. If you had a global in front of a using directive, which has to be on the top thing, has to be at the very top in the file, then this will be available throughout your entire project. You never have to use this namespace anywhere in the project again. Everything will have these types included automatically. And again, I just want to show you this as well. Let's first take test here, and we're going to skip this variable. And let's say that we're doing a method call, and based on the result of that method call, I want to create a switch expression, and we're going to make this a little bit readable again. Let's do this. And now I want to capture this. I can use a declaration pattern to say the test, for example. And now I can use that in this portion here to access the properties on this actual concrete type. So this will ensure that it's actually an instance of a past object, but it will be only declared inside the scope of that expression body. It's quite nice. And we can even take the same approach, take this portion here, and do this. Not going to get rid of all the code, because that... Actually, let's do this. If get test is that... Come on, there we go. I can do that as well. So I can capture the result of that method call and check that the actual return type is a value, and then declare this to a local variable that's only available in the scope of this if statement. And this entire thing is also a top-level statement. So this is the program.cs file introduced in C#9 as well. And this is to build up for what's known as minimal APIs, which is a new way of building APIs in C#. All right, so let's now talk about C#10. C#10 built upon the same thing. They improve records a little bit by introducing the same functionality for structs. The only difference is that structs are not immutable by default. Value-based equality still gets the same implementations as you'd get with the record class. If you want to make it read-only, you have to append the read-only keyword as well. How many of you using structs? Oh, that's more than I would have expected. So about a handful. C#10 also added some other things like the global using directive, the file scope namespace. They extended the property pattern so that if you do a nested property pattern, for example, if I check the test date and then did test date.year, it would also ensure that the actual property is not null. Before C#10, you'd have to explicitly check every property that you accessed, which was a little bit annoying and created code that wasn't really that readable. They improved lambda expressions a little bit, LO constant, it interpolated strings, and some other things as well. There's a little bit more than this here, but again, C#10 didn't really add a whole lot. And that's because they tried to focus on stability and just making sure that the features already existing were good enough. They added the support for global using directives and the file scope namespace and the property patterns extension. Those were enough for this iteration of the language. Now, I'm not saying that these are small features to add, though. One of them is the infer delegate type and improved lambda expressions. In C#9, you had to explicitly define which delegate type that this anonymous method was actually producing, which was very annoying because I can clearly see here that this here is going to take a string and it's going to return an integer. So why wasn't the compiler smart enough to know this as well? And of course, by C#10, it got smart, and now we can just do var, and then it will just infer that for us. And now, speaking of those minimal APIs and the improvements to both lambda expressions and working with smaller applications, they added attributes for lambdas as well. This here is in fact a minimal API. What this does is that it maps /get, an HTTP GET, to /ID, and I can call this from the web browser and it just works. There's just a couple of more lines in my program.cs to make this work. But before we were not able to use attributes on lambdas before C#10, which made these minimal APIs a little bit limiting. But again, they keep introducing and adding to the already existing features, making it more complete and making it a little bit easier and better to work with. All right, so let's now talk about C#11 before we jump over to Visual Studio. I have a couple of interesting things that I'd like to show you. One of them being the improved and added list patterns. So we have patterns for checking the contents of a list. We can slice off portions of a list, and we can also check contents of a span. There's a name of parameter. They are now caching delegates for static method groups, which is a performance improvement. If you've ever profiled applications and run into this being a performance problem, it's now fixed. And you get this by simply recompiling the application and using the latest version of .NET. There's also a new thing called a required keyword. So on properties, we can now say that a property on a certain class is required to be specified. So by C#8, they introduced what's known as nullable reference types. How many of you have heard of that? Almost all of you. So nullable reference types is a way for us to change how we look at reference types. We can now no longer assume that anything can be null. The compiler will now think that everything that's not explicitly defined as nullable should be set to a value. But before adding the required keyword, which is what we add before a property, the code becomes a little bit difficult to read, or actually it becomes a little bit annoying because we have to add more code to get rid of some warnings. And I'll show you this in just a moment. We also have raw string literals. We have static abstract members and interfaces, UTF-8 string literals, which allows us to now say that I have this string here, don't convert that into UTF-16. C# is traditionally just UTF-16. Every string in C# is UTF-16. Everything from the web is UTF-8. So if you get a stream of data coming from the web and you want to compare that to a string in memory, that has to first be converted into UTF-8. Which is a little bit annoying because that requires extra allocations, extra CPU processing power, and we don't have to do that anymore. There's generic math support, there's generic attributes. I don't know why this took so long either. Now, I don't work for Microsoft or on the compiler team, so for me, it just feels like they should have just added all of this in version 1, which would have meant we would never see C# at all. So generic attributes is something that I've wanted personally since probably I did traditional ASP.NET and web APIs back in the day. There was also this language feature called parameter null checking. We could use double bangs, which was actually withdrawn. So I'm not going to spend a lot of time talking about that. But being open source means that they will take inspiration and take input from the community, meaning that we can tell them what we like about these features and what we don't like. So let's jump over to Visual Studio and have a look at a couple of these different things. First off, I just want to show you here that the nullable reference types allows us to explicitly define that something can be null or set to a null value. A string is traditionally always going to be null, but without the question mark here, it's going to assume that this is set to a value. In previous versions of C#, we had to explicitly say that this here was set to, we promised the compiler that this has been set to a value. Default exclamation mark means that I forgive this for being null. This isn't very nice. And in a lot of projects, I see this for every property. Oh, is the right expression. So with C#11, they actually fixed this. We can now say that this is required. The warning goes away. And wherever I create an instance of this, we will instead get a compiler error. So now we can see here that first name is actually required to be specified. I have to set this to a value. I promise. I'll set this to a value. Yay. So it's not proof for everyone. It's not, yeah. So we want to set that to a value. And this here is the target type new expression introduced in C#9. So this here, I'm using yield return because I don't want to set up a temporary list here. Basically, I'm saying create a new thing that this list here assumes that it wants. It wants a person. Create a new instance of that. And then for the details property, give me a new, whatever class that needs. I don't have to specify exactly what that contains. I know that this is kind of a divider. Some people think this makes it harder to read, but I tend to like less code. Like I can use Visual Studio to figure out exactly what this is. All right, so that's the improvements to the nullable reference types, basically. And by introducing nullable reference types in C#8 and then continuously working on this language feature up until C#11, it's just a proof that Microsoft keeps investing in the language features already added. And they add more things to make it a little bit less of a problem for us to work with. Now, for the rest of the C#11 features, there's a couple more patterns. Here I have a collection of some hexadecimal numbers, and I like to use hexadecimal numbers because, frankly, it makes me look like a hacker. So I have a byte array that I've set to a couple of different values, and I'd like to check with a pattern to say that if this payload is actually set to an instance and that the first element is of this value, and I don't care if there's more elements following that or what those elements are. Right? I can also say that, how about if the payload contains that first element, I don't care about the second one, so the discard will always mean that it has to be present, but I don't care if it's null or if it's set to some specific value. Then I'd like to slice off the last portion of that list. Now, being a byte array, that means that we will produce some extra allocations. This will slice off the byte array and give that put that in a new memory allocation, basically. But it will only contain these two elements, so it will copy those over. Then for the final pattern that they introduced is what's known as a span pattern. How many of you have heard of spans? Okay, almost everyone, or half. Spans are a way for us to represent arbitrary memory, like be it on the, or managed or unmanaged, be it on the heap or the stack. We can represent really anything. It's basically pointers. So here, I've taken my string, it's allocated somewhere in memory, and now I'm using a span to point to the start and the end. The reason we want to do this is because the structure allows us to slice off portions and do that very memory efficiently. And now this here is really just a character of a memory somewhere, an array or a list of characters. And I can use this span pattern to say that, well, if this thing I'm pointing to is the same as this constant string, that's really what this pattern is doing. I don't have to convert it into a span myself. And let's look at one more example from C#11, where I'm using the same idea. I'm using a read-only span of a byte here. I'm taking my name here and converting that into a UTF-8 string living in memory. And now I'd like to produce some allocation-free slicing of this. I'd like to slice off my first name and last name. The way that I do this is by first finding the space, by saying take my full name, find the first index of a UTF-8 space, and then use this slice syntax to slice off the first portion up until the space, and then skip the space and slice off the rest of that string. All of this is actually allocation free. I will have two separate references pointing to one points to the first section and the second points to the second one. And with .NET 9, they'll actually improve this by adding a split on strings and arrays as well to allow you to do this without having to first find the index of it. But this here is a very memory efficient way of working with collections of data. Next up, we have something called raw string literals. The raw string literals, simply by using 3 double quotes, allows us to write XML and JSON and HTML inline. So our minimal APIs can now look like PHP. Yay! All right. Now I think this is a good feature. And we get syntax highlighting as well, so they really want us to use this. All right, let's see here. Let's go and talk about C#12. There's a lot of things happening with C#, and again, like being the 12th iteration of the language, there's a lot happening here as well. They took the idea from using record types with that primary constructor syntax and applied that to classes as well. It's a little bit different, and I'll show you why in just a second. There's this concept of collection expressions and a spread element. There's something called interceptors, optional parameters in lambdas, alias any type, inline arrays, ref read-only parameters, and an experimental attribute. The experimental attribute is the opposite of the obsolete attribute. So if you're writing code that's a little bit like, in the beginning phase and not sure if it's working properly, you have the experimental attribute and you have to opt in to actually use it. I add this to all my code. My coworkers hate me. Kidding. Probably shouldn't do that. I'm going to show you more ways of getting fired. All right, let's first look at the collection expressions. So collection expressions, we saw a sneak peek of this in just a second ago, but basically, there's no new list, new array, or anything in front of this here. This here, using the brackets here, is just a way for me to express that I'd like to produce a collection of these elements. And it will look at the left-hand side, in this case being a list of a byte. It will produce a list with that contents. I can change it to be a byte array. I can change it back and change this to a span, and it will just work. The collection expression will figure it out for me. It's nice when we're passing things into methods, if we have the constant values or whatnot, because then the compiler would choose the most appropriate overload as well. So this is a really nice addition to the language. Now, I have my payload here. I have a checksum. And actually, let's change this back to a list, because they are more different. A list and a byte array. I like to take these two and create a new collection, where the payload is in the front and the checksum is at the end. As you'll see here, I've copied all these elements over. I don't like to do that. So instead, what I'm going to do is I'm going to take my payload, and I'm going to spread this across the beginning of that array. Now, this is a spread element, so it's taking all the contents of that payload and copying it into this new collection. And I can do the same for the checksum. And it's not limited to doing this more than, you can do this as many times as you want. Don't take a photo of that. Let's go back. All right. Next up is the primary constructors. Primary constructors, again, takes this idea of adding the required properties or parameters to the constructor of that type. Now, this wouldn't make sense for a DTO or like any data class. It makes sense for controllers and view models and so forth, where you have like a million dependencies, which again, you probably shouldn't have. But I tend to have a lot of repositories and services injected, and I'd never liked the idea of adding a separate constructor that just sets the private fields in that class. So this here will just set a private field in the class. It will not be exposed outside of this class unless you explicitly do so. But I can use it in a method inside this class if I'd so like to. Finally, for C#12, there's this concept of an interceptor. An interceptor is pretty much like IL weaving, so it can replace functionality when you compile the code. So I've created an instance of this logger. If I go into this logger.log, which has hello world sent into it, we can see here that it simply calls log internal. If I step into that, we will see that this will throw an exception. Now I'm going to run this code. And hopefully, it will build the application, it will run it, it will say hello world in the console. But this should have thrown an exception. It didn't, because what I've done is that I've written code that will replace that call by adding this instead. So there's an extension method for the logger class that allows me to write this to the console. So let me show you where that replace happens. I'm going to undo that again. I've added a class called interceptor. This here is an extension method for that class. It takes the logger, has the same signature as the one that I've called before, but writes to the command line or to the console. I have to point to the exact file, to the row, and to the column. But if we have source generators that we add through NuGet packages, they could very easily do this during compile time. And what you'll also notice is that I won't be able to step into this using the debugger, because I've added debugger hidden, which is another funny prank to pull on your coworkers. So this might seem dangerous, but this is an opt-in feature, so I actually have to go into the project file and say that I allow interceptors from these different namespaces. So don't be scared of using NuGet packages that simply creates these source generators for you. So there's a lot happening in here, right? And they're actually used quite heavily inside. For example, ASP.NET Core uses it for improving performance. And that's where it's really powerful. So it can go ahead and look at your solution. If you're targeting a specific platform, or in this case, using ahead-of-time compilation, it can produce code that's specific for that platform and replace code that it knows is slow with the new interceptors. So finally, we're going to spend a couple of minutes talking about C#13. C#13, again, builds upon some concepts and features that have been around for a long time. And what they want to do is to now make it, again, easier for us to write less code. Basically, all the features that they've added to the language is just to reduce code, make our applications more robust, and allow us to express ourselves a little bit differently. One of these is a new field keyword. So if you have an auto property and you've ever wanted to do anything like modify the value slightly before setting the private backing field, you haven't been able to do so. But now there's a new keyword called field, so you can reference that generated backing field. There's also ways to use params with collections. There's a new lock object in semantics. There's implicit index access, overload resolution priority, partial improvements, and potentially a couple of more things. It's still a week away, right? So we'll see what Microsoft does in that final week. Maybe they'll just remove all of them. Now, I don't think so. There's a couple of cool things here. So the field keyword, notice here, if we take a look at this. So I've referenced field here, and that is actually now referencing, it's a contextual keyword that will reference the backing field that's generated for this property. So I can use this when I set the value. I can use the value and trim it before I actually set my backing field. I could do a whole lot more with that before setting it, or even clean it up when I return it. Probably be better to actually switch these around, because you should probably store the actual value and clean it on the way out. But then what happens if I already have a backing field called field? That's a breaking change. Things will blow up. Well, actually, it won't blow up. Your current fields will actually not be used. Since this is a contextual keyword, what you have to do is use using the keyword escaping. So you'll see here the @ symbol. Everywhere, if you have a backing field or a private field already called field and you use that in an auto property or a property, it will no longer be referencing that variable. It will actually be referencing that new backing field. So you have to add the @ everywhere. I think this is the first time they add a breaking change to the compiler. Like, I don't mind, but there's going to be warnings when you build your application that you have a unused variable or unused member in your classes. And everyone looks at their warnings and just fixes them, right? You're all laughing. All right. All right, and then we have the params collection. So here I have the params keyword in front of all of these different collections. And this builds on that notion of using the collection expressions. It works with spans, it works with read-only spans, it works with all different enumerables, and it will try to avoid implicit conversions. If we have, like for example, if we have a span and an array, the span will take precedence. It will use that instead, because it will assume that it's a little bit faster. But you'll notice, probably won't notice here, but at the bottom here, you can see that I have my name here and my wife's name are passed as either just comma-separated strings or in a collection or in a list. They will all just work. However, in this case here, this will actually be ambiguous. If someone actually spotted that, I would be tremendously impressed. So what's happened here, it won't actually know which one is more suitable, which brings us to the next really amazing feature. It's the overload resolution priority attribute. Which I can't say more than once. All right, so we can add this attribute here, and we can determine which one to use if there is like an ambiguity. The higher value, of course, takes precedence. So I'd like to use the read-only span instead of the list of a string if I can. All right, and then there's a new lock object and a new lock semantics. This will provide a better thread synchronization through a new API. This is added in the .NET 9 runtime and will hopefully introduce less confusion. It will be easier to work with as well. And instead of using this monitor-based API that they had traditionally, this should be better. You shouldn't really use locks anyways, but if you do and build multi-threaded applications, this is a nice addition. Then they build upon the partial. So we have had partial classes for a very long time. We've had partial methods for a long time. And now we can also have, if you see here, I have a partial property, my name here. You're probably wondering why this is a good idea. Well, it's because you can have source generators that could generate the implementation. Very much like you have the iNotify property change source generators. This could generate some code for you as well. The final feature of C# 13 is the implicit index access. So I can say here that I'd like to set the last element to 5. I'd like to set the second last element to 4. And I can do that as well. So this is a nice way of accessing those different elements. And if you've kept up with the updates of C# and looked a little bit at what's happening in C#, you might have heard about this thing called extensions everything. Basically lets you extend on any type to add properties, methods, and whatnot. But they postponed that to C# 14. So there's a reason for me to come back next year. Probably won't have an hour to talk about or 40 minutes to talk about extensions everything. But that's a nice feature. I'm looking forward to that as well. They've talked about this since probably C# 6. So eventually this will come to the language as well. So I guess with 20 seconds left, what's next? There's probably a lot happening with the language. There's going to be more improvements. There's going to be additions to what's happening with the language. And if we just upgrade to .NET 9, you'll benefit from all these different performance improvements as well. If you like this, I have a ton of courses on Pluralsight where I go through all of this in a little bit slower pace. I hope you've enjoyed this. It's been kind of a roller coaster of going through all the different language features and what's happening with C#. But hopefully this gives some inspiration as to how you can use this in your projects. All right, my name is Filip Ekberg. Thank you so much.